Good evening. Today we are going to be learning about multiplying and dividing polynomials by monomials. This is lesson 14.3. In 14.3 the book is totally devoting itself to multiplying polynomials by monomials. I have added the dividing part because that's also included in your EOC. So we need to be learning that concept too. So multiplying and dividing polynomials by monomials. Before we get into multiplying them by polynomials, we are going to learn about multiplying a monomial by a monomial, because we know that polynomial is a collection of monomials. So if we know how to multiply a monomial and a monomial, we'll be able to multiply a monomial and a polynomial. So the first example I have here is, I have a monomial 2x to the power of 4 multiplied by negative 3x to the power of 5. So you can see that yesterday when we were talking about adding and subtracting polynomials, I was telling you guys that it'll be differentiated using a parentheses, and whatever is in between the parentheses is the operation that's taking place between the two polynomials. So as you can see, this is a monomial and this is another monomial separated by two parentheses, and the operation in between is a multiplication. I don't see any sign there, so multiplication is understood. So here I have two monomials being multiplied. So even within the monomial, I'm only seeing multiplication between 2 and the x to the power of 4. And here negative 3 and x to the power of 5, they're all being multiplied. So it's one big multiplication party that's going on. So this is 2 times x to the power of 4. And I have this multiplication. That's negative 3 times x to the power of 5. So I'm going to multiply the number and the number. 2 times negative 3, and I have the x to the power of 4 and x to the power of 5. These two guys are similar exponents because they have the same base. So multiplying exponents of the same base, I'm going to add the powers. These two guys I'm going to multiply. So 2 times negative 3 is going to give me negative 6. X to the power of 4 times x to the power of 5. This is x to the power of 4 plus 5 will give me a 9. So multiplying these two, that's my answer. So next example, I have 8g square h power 5 and 6g h to the power of 3. Here I was dealing with only one variable. Here polynomials can have more than one variable in their terms. So another example with two variables in each term. So I have 8g square h power 5, one of the monomials, multiplied by 6gh cube, another monomial. I'm seeing that there is a multiplication in between them. So this is again a whole multiplication party. So it's 8 times g squared times h power 5. I have this multiplication sign there. 6 times g times h cube. So I'm going to multiply the numbers together. So it's 8 times 6. I'm going to bring all the like ones together. I have g squared times g to the power of 1. And I have h to the power of 5 and h to the power of 3. So I'm grouping them together. So 8 times 6 is going to give me a 48. G squared times g power 1 is g cubed. H power 5 times h power 3 is h to the power of 8. So multiplying these two monomials gives rise to this monomial. So that's multiplying a monomial by a monomial. So next topic is multiplying a monomial and a polynomial. Alright, multiplying a monomial and a polynomial. So this is a monomial here. Finding the product, because multiplication gives rise to a product. So 4m cube n square, and I have a polynomial 5m square n minus 3mn minus 2. So I have a monomial multiplying a polynomial. Alright, so here earlier we have learned about distributive properties. Say I have 3 times x plus 5. All I do is I just distribute the 3 to both of them, right? So I have 3x plus 15. So this is nothing but distributing, but I'm not distributing just one number, I'm distributing a monomial to everybody. So this is 4m cube n square times 5m square n minus 4m cube n square times 3mn minus 4m cube n square times 2. Alright, so I'm just distributing the monomial to all three of them. So now as you can see, this is monomial times monomial, this is also monomial times monomial, monomial times monomial. We just did that, right? So this is 4m cube n square, 5m square n. So what we did there was multiply the numbers, so I get a 20. M cube and m square are alike, so m cube times m square is going to give you m to the power of 5. I have n square and n to the power of 1. N square times n to the power of 1 is n cubed. So multiplying this monomial and this monomial gave rise to this. Next one I have a minus. 4 times 3 is 12. M cubed times m to the power of 1 will give you m to the power of 4. N square times n to the power of 1 will give you n cubed. The next is minus 4 times 2 is 8. I don't have any variable part to this 2, so I'm just going to keep the m cube and n square. So this is my monomial times a polynomial. Okay, we can do another example. 2x times 3x square plus 2x minus 4. Example 2. So I am distributing 2x to everybody. So it's 2x times 3x square plus 2x times 2x minus 2x times 4. So 2x times 3x square, 2 times 3 is 6, x is x to the power of 1, x times x square is x cubed, plus 2 times 2 is 4, x times x is x square, minus 2 times 4 is 8, x doesn't have anything, I'm just keeping the x. So multiplying a monomial and a polynomial. We can do another example just to make sure that we understood this part. I'm going to choose a complicated one. So let's say I have 3ab times 2a square b plus 6ab square plus 8b. Okay, so I'm multiplying 3ab times 2ab square. So after you get used to it, you don't have to do all this, you can just do it mentally. Yeah, so 3ab times 2a square b plus 3ab times 6ab square plus 3ab times 8b. Alright, so 3 times 2, 6. A times a square is a cube. B times b is b square. Plus 3 times 6 is 18. A times a is a square. B times b square is b cubed. Plus 3 times 8 is 24. I don't have an a there, so I'm just going to keep an a. B times b is b square. So multiplying a monomial by a polynomial. Alright, so the next topic is dividing a polynomial by a monomial. Finding the quotient or just dividing them by dividing the polynomial by a monomial. Alright, so earlier we said that multiplying is multiplying every single term with that monomial, right? Multiplying multiplying every single term with that monomial. So when it comes to division, I'm dividing every single term with that monomial. So if I have to divide this is actually 9x cubed minus 6x squared plus 15x divided by 3x squared, right? I'm dividing every single term by that 3x squared. So this is actually 9x cubed divided by 3x squared minus 6x squared divided by 3x squared plus 15x divided by 3x squared. Alright, so here 9 divided by 3 is 3. X cubed divided by x squared. This is power of a quotient, yeah? Powers of quotients, right? So I have the same base and I can subtract the exponents. So 3 minus 2 is 1, so 3x. Minus 6 divided by 3 is 2. X squared divided by x squared is 1, so I don't have any variable there left. So plus 15 divided by 3 is 5. X divided by x squared is I can cancel one of those x's. So there will be an x remaining in the bottom, in the denominator. Okay, so after I divided all the monomials by this monomial, I get my polynomial. Sorry, this is not a polynomial. Okay, so I got my answer, I got my quotient. So 3x minus 2 plus 5 over x. Dividing a polynomial by a monomial did not give rise to a polynomial as an answer, because in a polynomial I cannot have variables in the denominator. If you remember the rules that we learned, I cannot have a variable in the denominator. So this is not a polynomial. So this gives rise to the closure property. Closure property of polynomials. When I add two polynomials, polynomial plus another polynomial will always be a polynomial. A polynomial minus a polynomial, meaning when I subtract a polynomial, when I subtract two polynomials, my answer will always be a polynomial also. When I multiply two polynomials, my answer again will be a polynomial. But when I divide two polynomials, I may or may not get a polynomial as an answer. Okay, it may or may not be a polynomial. I cannot say for sure. So that way I can say polynomials are closed under addition. They are closed. Polynomials are closed under addition, subtraction, and division and multiplication, but not closed under division. Okay, so this is similar to integers. Integers behave the same way. When I add two integers, I get an integer. When I subtract two integers, I get an integer. When I multiply two integers, I get an integer. But when I divide two integers, I may or may not get an integer. So polynomials are just like integers. Polynomials are like integers. Okay, so please remember that. Alright, so we are done with this lesson. We can continue in our next. Thank you.